Alright, so this video is very similar to the last one. It's just going to be inequalities instead of equations. So on this, we still want to get the absolute value piece by itself. There's just going to be one slight difference at the very end. So on this first one, I'm still looking to get the absolute value of x plus 2 isolated or by itself. So I need to move the 6. Divide by 3 to get the absolute value by itself. Now, just like the last one, when we get the absolute value by itself, we need to break the equation, or the inequality, break the inequality up into two different forms. Because absolute value is distance, therefore, if whatever's inside the absolute value is bigger than 4, our equation is true. Or negative 4, because the absolute value of 4 and the absolute value of negative 4 are the same thing. However, going back to our little Algebra 1 days, when you multiply or divide a inequality by a negative, so we changed our 4 to a negative 4, we must flip the inequality sign. It's the only difference here. You got to flip the inequality sign the other direction only when you change it to a negative. So here we get x is greater than 2, and we get x is less than negative 6. Both of those are true. Sometimes I will ask you to write your answer on a number line, or you may see some answer choices that have number lines as answers. It's just kind of an easier way to represent your thoughts. So if we have a number line, let's say this is negative 6, this is 2, which makes 0, like right there. When we're doing this, we know that x greater than 2 is true. So we put a dot and then draw an arrow to the right because that's where numbers bigger than 2 are. But also, if x is less than negative 6, and numbers less than negative 6 are to the left. So we draw an arrow to the left. The key here is, should the dot be open or closed? And how I know that it's open is the inequality down here. If the inequality has the equal to line, which is the little line underneath, then that means it's greater than or equal to. But since this does not have one, it means the actual values of 2 and negative 6 don't count. Because 2 and negative 6 are where the absolute value is equal to 6, but that's not what it's asking us for. So we just put an open dot instead of a closed. So if there's a line, we fill in the hole, like color it in. If there is no line, we leave it open. The next two actually require no work, just a little common sense, which some of us may be groaning because they'd just rather do work than have to think for a minute. So the absolute value of x plus 2 greater than negative 6. It's asking me, the absolute value is a representation of distance, which we've talked about over and over and over the past week or two. We never report distance as negative, therefore, absolute value will never come back as a negative. So if the absolute value of x plus 2 is always positive, this is really asking, where are positive numbers greater than negative numbers? Well, where are positive numbers greater than negative numbers? Everywhere. There is no scenario where you will get a positive number and that is less than a negative number. So, there's two different ways that we'll see this. I don't care which way you do on a short answer question. Just know multiple choice, these mean the same thing. So you can write infinite solutions, which means, everything works, or probably the more mathematically correct is all real numbers. And that's the number symbol. You can write the word numbers if you don't want to put the hashtag. But all real numbers just means any number you can think of, it's going to work. So the third example is very similar. The absolute value of x plus 2 is less than negative 6. And just like the last one, the absolute value is always positive. So this one's really asking where are positive numbers less, where are positive numbers less than negative numbers? Well, that's impossible. You will never have a positive number that is less than a negative number. Therefore, we have no solution. Nothing works. And again, on the second example, you don't have to write both those things. Just pick your favorite. But on multiple choice, I just want you to be prepared that those mean the exact same thing. So solving algebraically inequalities are the same principle as solving equations algebraically. The only difference being this little green inequality in the bottom. When we break off into our two equations, where we change the other one to a negative, we need to be careful and flip our inequality sign as well. So I actually have two graphing examples in this video. With inequalities, you may or may not remember, but with inequalities, we actually have some shading that we need to do. So I'm still going to graph the left side just like the last video. I'm going to graph the left side and graph the right side. So the vertex is 1, 2. So we're going to put a dot at 1, 2. And then we have a slope of 1. So I'm going to go up 1 and over 1 in both directions. And then I want to know, where is this purple V, where's the absolute value greater than 3? So, with shading or with inequalities, we do need to remember that when there is not a line underneath, that is a dotted line. And when there is a dotted underneath, that is a solid line. So when we're doing this, you can just do the absolute value like normal if you want. But the constant value, we're going to need to determine, do we dot or draw a line like normal. So it's greater than 3, not greater than or equal to. So when I draw my line for 3, I just need to make sure it's dotted. The only thing left to do is just to decide where I shade. So to decide where I shade, I need to kind of understand what we're looking for. We want to know where the purple part of this graph is greater than 3, or the green part of the graph. There's really two options to shading. We're either going to fill in the triangle, and what I mean by that, the triangle is right here. So we're either going to fill in the triangle, or we're going to color in the wings. And what I mean by the wings is the outside part. I'll get to that in a second. So if I'm looking where the purple part is greater than 3, well, the numbers greater than 3 are up here, right? The bigger numbers are up. So if I color in this triangle down here, is that triangle greater than the line of 3? And hopefully we can put together that the answer is no. That is less than, because it is below the green line. Therefore, we must shade the wings, not the little triangle part. Because if you look up here, the purple part of the graph that is above the green line is out here. So again, we're either shading the wings or the triangle part. And the reason I call them wings is after you shade it in, kind of looks like a wing. Not, I know it's still math, so it's not like a art wing, but it's close enough. The last example is just going to kind of show us the other way to shade. I guess, spoiler alert. So we're either going to shade the triangle or the wings when we're finished. But here I'm going to graph it the same. The vertex is -2, -3. The slope is 1. So I'm going to go to -2, -3. And I'm going to go up 1 over 1. And draw my absolute value. And then again, just like the last one, I need to check, is it dotted or solid? Since this inequality is less than and not less than or equal to, I know when I go to 1 and graph it, I'm going to use a dotted line. Now, the last thing we need to do is to determine, do I shade the inside or the outside? Do I shade the triangle or do I shade the wings? Well, I want to know where the absolute value or where the blue piece is less than the green piece. So, if I shade the wings like I did last time, the wings are above the line. If the wings are above the line, that means they're greater than the line, but that's not what it's asking. It says, where is the blue part less than 1? Well, it's less than 1 down here in the triangle. So in this case, we would fill in the triangle because that's the part that's less than the line of 1, or the quantity of 1. Hopefully that helps. I know this was kind of a longer video. It'll be easier in class, the shading part, when you can ask me questions and it's more interactive. But hopefully that gives you the general idea.